September 12, 1943. Luftwaffe High Command, Berlin, Germany. Oberst Heinrich Vogel lifted the intelligence report from his desk, his iron-gray mustache twitching with barely concealed amusement. His fingers, manicured despite 4 years of war, drummed against the leather blotter as he scanned the American claims. "Look at this," Vogel said, sliding the document across the polished mahogany to his adjutant with the casual dismissiveness of a man who had seen 100 enemy propaganda efforts. The Americans claim their new shells can sense aircraft without contact, magic bullets that explode at precisely the right moment. Hauptmann Otto Krebs leaned forward, his Knight's Cross catching the autumn light filtering through the tall windows. "Impossible, Herr Oberst. Our engineers confirm no such technology exists. The physics are unworkable." Major Wilhelm Adler, Chief of Technical Intelligence for the Western Front, shifted uncomfortably in his chair near the window. "Herr Oberst, our agents report unusual production activity at American facilities. Something has changed in their manufacturing." But Vogel waved him off with the confidence of a man whose pilots had ruled European skies for 3 years. "Changed? We destroyed 42 American bombers over Schweinfurt last month with acceptable losses of 15 aircraft. At Ploesti, they lost 54 bombers. At Bremen, 30 aircraft fell in one afternoon. Our kill ratios remain superior." At Schweinfurt-Regensburg, the exchange was 2-8-1 in German favor. At Hamburg, 3-1-1. At Kiel, 2-4-1. The mathematics were undeniable. German fighter superiority remained unchallenged. What Vogel didn't know, what none of them could have known as they reviewed intelligence summaries in that sun-drenched office overlooking Unter den Linden, was that the VT proximity fuse would destroy 8,400 German aircraft within 18 months. The numbers would become catastrophic. Kill ratios of 40, 1 in naval engagements, 15, 1 in ground-based air defense. American factories would produce 22 million proximity fuses by war's end. German losses would exceed their entire pilot training capacity by spring 1944. The confident dismissal in that Berlin office would become history's most expensive miscalculation, measured in 12,000 irreplaceable Luftwaffe pilots and crew. The confidence came from experience. German fighters had dominated the skies since Poland. Their pilots averaged 340 combat hours before first engagement. Their aircraft climbed faster, turned tighter, hit harder than anything America fielded in early 1943. Oberst Vogel himself had 31 confirmed kills across 3 fronts. His Jagdschwader had achieved a 4-2-1 kill ratio against American heavy bombers throughout the summer. At every major engagement, German fighters proved their superiority through mathematical certainty written in burning aluminum falling from 25,000 feet. The Focke-Wulf FW-190 mounted 4 20mm cannon and 2 13 machine guns. Rate of climb, 2,950 feet per minute. Maximum speed, 408 mph at 20,600 feet. Service ceiling, 37,400 feet. The Messerschmitt Bf-109G carried 1 30mm cannon through the propeller hub, 2 13 machine guns above the engine, and could mount 2 additional 20mm cannon under the wings. These were not propaganda specifications. These were proven combat numbers confirmed in thousands of engagements across 4 years. American performance had been disappointing. B-17 formations lost an average of 6.2% per mission over German territory in summer 1943. The 8th Air Force suspended daylight operations twice due to unsustainable losses. At Schweinfurt, they lost 20% of the attacking force. At Regensburg, 16%. The mighty American bomber formations were being systematically dismantled by German fighters that could attack from any angle, break off, rearm, and return before the bombers reached safety. Oberst Vogel had personally led the intercept at Hamburg on July 25, 1943. His squadron destroyed 7 B-17s in 11 minutes without loss. He remembered watching the American gunners firing their .50 caliber machine guns in desperation, the tracers falling short as his fighters climbed beyond their envelope. "They bring heavy bombers," he had told his pilots afterward, "but they cannot protect them." The mathematics of speed, altitude, and firepower favor us absolutely. Major Wilhelm Adler had tried to present his concerns 3 times in August. His reports detailed unusual construction at American facilities. British intelligence suggested revolutionary electronics. Captured documents mentioned VT, but provided no technical details. "Herr Oberst," Adler had said during the August 30 briefing, American production capacity is increasing at rates our models cannot explain. They are manufacturing something in quantities that suggest a major technical initiative. Vogel had dismissed him with a gesture. Major, the Americans manufacture automobiles and refrigerators well. They do not manufacture military technology better than the Reich. Their industry produces quantity. Ours produces quality. Every combat engagement confirms this. Unteroffizier Franz Müller had experienced this superiority firsthand on August 14 over Stuttgart. His gunner had fired 900 rounds at attacking American fighters during a bombing run. He estimated 37 hits on one P Thunderbolt before it broke off smoking. The P-47 returned 15 minutes later, apparently undamaged, and destroyed his wingman. The Americans build strong aircraft, Müller had reported, but they cannot shoot accurately. Our fighters destroyed 4 B-17s from our formation. The American escort destroyed 1 Bf-109. The exchange rate remains favorable. The mathematics seemed irrefutable. Washington, D.C., September 1942. Dr. Merle Tuve adjusted his spectacles in the basement laboratory of the Department of Terrestrial Magnetism, watching the oscilloscope trace that would change warfare forever. The Johns Hopkins Applied Physics Laboratory had achieved what German engineers called impossible: a miniaturized radar transmitter and receiver that could survive the 20,000 G acceleration of an artillery shell, operate reliably at 40 below zero and 125 degrees Fahrenheit, cost less than $20 per unit, and be manufactured by workers with no electronics training. In January 1942, America produced just 327 proximity fuses monthly, each one hand-assembled by experienced technicians. By March 1943, production reached 40,000 monthly as assembly line techniques replaced artisan methods. By July 1943, the Eastman Kodak facility in Rochester, New York, was producing 48,000 fuses daily. By September 1943, a single American factory was producing more proximity fuses daily than the entire German electronics industry produced vacuum tubes monthly. This single facility was producing more than the entire Reich's radar manufacturing capacity. The production progression followed American industrial logic. In January 1942, America produced just 327 VT fuses monthly, each requiring 6 hours of skilled technician time. By June 1942, production reached 8,400 monthly as specialized equipment replaced hand assembly. By December 1942, monthly output hit 127,000 units as multiple facilities came online. By March 1943, production exceeded 340,000 monthly as worker training programs produced 2,400 new assembly workers weekly. By September 1943, the single Eastman Kodak facility in Rochester was producing more VT fuses daily than Germany's entire electronics industry produced comparable components monthly. Mary Catherine O'Brien, previously a department store clerk from Buffalo, New York, now operated the vacuum tube insertion station at Rochester's Building 65, producing 2,840 completed fuse assemblies every 8-hour shift. She worked one of 47 identical stations on the 3rd floor. Her single station's daily output exceeded the entire monthly production of Germany's Telefunken facility in Berlin. O'Brien never saw a completed fuse. She inserted 5 vacuum tubes into pre-assembled housings, verified continuity with a simple go-no-go tester, and passed the assembly to the next station. Every 18 seconds, another assembly moved through her station. She produced more functional radar receivers in one shift than the entire German Navy acquired in all of 1942. The mathematics of American mass production made individual German craftsmanship irrelevant. Her station produced 17,040 assemblies weekly. Telefunken's entire Berlin facility produced 11,200 radar receivers annually across all military contracts. Thomas Jefferson Washington, from Gary, Indiana, operated the antenna forming press on the 2nd floor of the Crossley Radio Corporation facility in Cincinnati, Ohio. His hydraulic press stamped, formed, and tested 4,200 antenna assemblies every 8-hour shift. Each antenna required precision within 0.02 of an inch to function properly at the designed frequency. Washington's press achieved this tolerance automatically. loaded copper blanks, activated the press, and removed finished antennas at a rate of 1 every 6.8 seconds. His single station's daily output exceeded the entire production capacity of Germany's Lawrence AG facility in Berlin-Tempelhof. Washington had worked in an automobile parts factory before the war. His training for the antenna press took 4 days. Lawrence engineers required 6 years of training. The American system didn't need engineers on the production floor. It needed engineers designing equipment that made precision automatic. Charles Henderson Foster III, $1-a-year man from Radio Corporation of America, managed the entire integration process that brought components from 47 suppliers, assembled them through 19 stations, tested them through 7 verification stages, and shipped them to 3 different military services. Foster had engineered the production system that turned complex electronics into a commodity product manufactured by workers who couldn't explain how a vacuum tube worked. The German approach, Foster told visitors, requires skilled craftsmen making custom products. We require skilled engineers making foolproof processes. They make radios. We make radio-making machines. The difference is measurable in orders of magnitude. Americans discarded 840 vacuum tubes daily at the Rochester facility. The tubes functioned properly but failed aesthetic standards for military specifications. Tubes with minor cosmetic blemishes were thrown into scrap bins and sold for pennies to civilian radio repair shops. Germany allocated 12 vacuum tubes monthly to each Luftwaffe radar installation. The discarded tubes from aesthetic failures at one American facility exceeded Germany's entire military electronics allocation. The waste represented American abundance. Germany rationed by necessity. America discarded by choice. The waste from a single day's testing exceeded Germany's weekly allocation of electronics components to the entire Luftwaffe. Technicians at the Crossley facility fired test shells into Lake Erie daily, expending 240 complete proximity fuses to verify batch quality. Each test fuse cost $18.37 to manufacture. Daily testing consumed $4,409 in materials. Germany's entire monthly allocation for radar research was $3,100 in equivalent resources. Americans spent more testing batches than Germany spent developing new technology. Workers at the assembly facilities threw away copper wire by the pound. Slightly kinked wire that might affect reliability went into scrap bins. Germany allocated copper wire to military electronics facilities by the gram, measuring monthly allotments in kilograms carefully distributed across all projects. The copper wire discarded at the Rochester facility in 1 week exceeded the entire monthly allocation to Germany's Telefunken, Lawrence, and Siemens facilities combined. Cafeteria at the Eastman Kodak facility discarded more food daily than the Luftwaffe radar station at Wandruge Island received monthly. Workers ate subsidized meals featuring beef, pork, chicken, fresh vegetables, dairy products, and desserts. Cafeteria waste from a single day's lunch service totaled 340 pounds of edible food. German military rations at radar installations averaged 2,200 calories daily per man, carefully calculated and delivered. American workers consumed 3,400 calories daily and discarded food casually. The waste represented surplus. German allocation represented maximum effort. The aluminum scrap from drilling and forming operations at the Cincinnati facility exceeded Germany's monthly allocation of aluminum to the entire electronics industry. Every fuse housing required 3 drilling operations that removed 0.23 ounces of aluminum as waste. At peak production, the facility produced 38,000 housings daily, generating 546 pounds of aluminum scrap. Germany allocated 480 pounds of aluminum monthly to Telefunken, Lawrence, and Siemens, combined for all electronics manufacturing. American waste exceeded German allocation. Major Wilhelm Adler received the production reports in late August 1943 and immediately requested an audience with Oberst Vogel. Herr Oberst, our intelligence indicates American electronics production has increased by a factor of 40 since January. They are producing something in quantities that suggest battlefield deployment rather than experimental development. We must assume they have solved a technical problem we consider insurmountable. Vogel had reviewed the reports with skepticism. Major, the Americans cannot miniaturize vacuum tubes sufficiently for artillery shells. The physics are clear. The acceleration forces would destroy any electronic components. This is propaganda meant to demoralize our pilots. I have reviewed this with our technical staff. It cannot be done. June 12, 1944. English Channel 48, 7 degrees N, 1, 2 degrees W, 4:47 hours. Franz Mueller was manning the dorsal gun position on Junker's Ju-88 G6 night fighter Black 12 when the radar warning receiver screamed. The Ju-88 was returning from a patrol over the channel, fuel low, dawn approaching. Oberleutnant Schaefer, the pilot, was already descending toward Caen when the British destroyer appeared as a dark shape against the lighter sky. At 0447:15, Schaefer banked left to avoid the destroyer's known patrol area. At 0447:22, the destroyer's main batteries opened fire. The first shell exploded 16 feet below Black 12's starboard engine. No tracer preceded it. No visible fuse sparked. The shell simply exploded at the precise distance where fragments would saturate a three-dimensional kill zone around the aircraft. Mueller felt the fragments tear through the fuselage before he heard the explosion. At 0447:23, a second shell exploded 12 feet from the port wing, shredding the aileron and severing control cables. At 0447:25, a third shell exploded 8 feet above the cockpit, killing Oberleutnant Schaefer instantly and wounding the navigator. At 0447:27, the Ju-88 entered an uncontrolled dive. At 0447:49, Black 12 impacted the channel at 340 miles per hour. Elapsed time from engagement to destruction, 34 seconds. Kill time, 34 seconds. Mueller survived because the dorsal gunner position in the Ju-88 G6 featured emergency blowout panels designed for exactly this situation. The impact with the water killed the pilot, navigator, and ventral gunner. Mueller regained consciousness in the water, his life vest inflated automatically. A British corvette picked him up at 5:12 hours. The British sailors were professional and polite. They gave him hot tea and dry clothes. They asked him questions about what he had experienced. Mueller told them about shells that exploded without contact, that knew exactly where his aircraft was located in three-dimensional space, that detonated at precisely the optimal distance for maximum lethality. The British sailors nodded. They had seen it before. The engagement summary from HMS Vixen's log read: 0447:15 radar contact, enemy aircraft, bearing 287, range 4,200 yards, altitude estimated 1,800 feet. 0447:18 main battery solution computed. 0447:22 4-inch guns, commence fire. 0447:23 burst observed, target altitude. 0447:24 second round burst observed, target damaged. 0447:25 third round burst observed, target control surfaces severed. 0447:27 target entering uncontrolled descent. 0447:49 surface impact observed, cease fire. Total engagement duration, 34 seconds. Enemy losses, 1 Ju-88 G6 night fighter, 3 crew killed, 1 captured. British losses, 0 personnel, 0 equipment. Ammunition expended, 3 4-inch VT fused shells. Standard engagement doctrine called for 40-round barrage fire against single aircraft targets. Kill ratio, 1:0. The ammunition expended in this 34-second engagement was 3 shells. A standard barrage engagement would have expended 40 shells and required 4 minutes of sustained fire with uncertain results. The VT fuse achieved instantaneous kill with 92.5% reduction in ammunition expenditure. Oberst Heinrich Vogel reviewed Mueller's interrogation transcript on June 19, 1944. He read Mueller's description 3 times. He compared it to 17 other similar reports from surviving German aircrews. He noted the consistency: shells that exploded without contact, no visible fuse glow, detonations at optimal lethal range, engagement times measured in seconds rather than minutes. Vogel wrote in the margin of the report, "Investigate technical feasibility immediately. If accurate, revise tactical doctrine for all operations within range of Allied naval vessels." Intelligence dismissed the initial reports as combat stress, survivor confusion, or British psychological warfare. The acceleration forces inside an artillery shell exceed 20,000 times Earth's gravity, the technical assessment stated. No vacuum tube can survive such forces. No miniaturized radar system can function after such stress. The reports describe technically impossible weapons. Pilots are misinterpreting conventional proximity bursts or time-fused shells that coincidentally detonated at lethal range. The assessment concluded that improved British gunnery and increased ammunition expenditure explained the observed results, not revolutionary technology. Major Wilhelm Adler reported to Luftwaffe High Command on June 24, 1944, with 16 consistent survivor accounts, captured British technical manuals referencing VT fuses, and reconnaissance photographs of American production facilities. Gentlemen, the British and Americans have deployed a proximity fuse that uses miniaturized radar to detonate shells at optimal range from the target. Our pilots report engagement times under 1 minute with near-certain kill probability. This represents a fundamental change in air defense capability. The mathematics are clear. If Allied naval vessels and ground batteries can engage aircraft with 90% kill probability in under 40 seconds, our operational capacity over Allied-controlled territory becomes untenable. American monthly production of VT fuses in June 1944, 870,000 units. German monthly production of comparable electronics components, 11,200 units. A single American factory, the Eastman Kodak facility in Rochester, exceeded Germany's entire electronics industry output by a factor of 78. American production of proximity fuses equaled Germany's total production of all vacuum tubes for all purposes across all industries. The Crossley facility in Cincinnati produced 340,000 fuses monthly. The Sylvania facility produced 280,000 monthly. The Eastman Kodak facility produced 940,000 monthly. 3 American factories produced more sophisticated electronics monthly than Germany's entire industrial capacity, produced across all technologies annually. Failed tactical adaptations began immediately. German fighters tried attacking Allied vessels from wavetop height where radar tracking was degraded. American destroyers adjusted tracking algorithms and achieved 87% kill rates against low-altitude targets. German aircraft tried high-altitude attacks above the fuse's effective range. American cruisers deployed 5-inch guns with VT fuses effective to 35,000 feet and achieved 73% kill rates. German bombers tried night attacks when visual tracking was impossible. British radar-directed guns coupled with VT fuses achieved 81% kill rates in total darkness. German command tried saturation attacks with multiple aircraft overwhelming defensive fire. American ships demonstrated that VT fuses required only 1 or 2 shells per target, regardless of the number of simultaneous targets, and defensive coordination allowed sequential engagement of multiple aircraft faster than conventional barrage fire could engage single targets. At 1834 hours on July 3, 1944, 6 Ju-88s attacked the destroyer HMS Onslaught in the Channel. At 1834, the first Ju-88 exploded from a direct VT-fused hit. Elapsed time, 22 seconds. Kill time, 22 seconds. At 1835:01, the second aircraft fell into the channel, its wings severed by fragments. Elapsed time from engagement to destruction, 39 seconds. Kill time, 39 seconds. At 1835:28, the third Ju-88 pulled away trailing smoke and crashed 2 miles distant. Kill time, 66 seconds. At 1836:12, the fourth aircraft disintegrated from 3 simultaneous bursts. Kill time, 110 seconds. At 1836:47, the fifth Ju-88 jettisoned its bombs and fled, severely damaged, crashing near Cherbourg 12 minutes later. At 1837:03, the sixth aircraft withdrew without attacking. Total engagement duration, 2 minutes 41 seconds. Enemy losses, 5 Ju-88 bombers, 15 crew. British losses, 0. Kill ratio, 5-0. The ammunition expended in this engagement totaled 23 4-inch shells. Standard doctrine would have required 240 rounds of barrage fire. Major Adler presented the engagement reports to command on July 8. We are not experiencing improved British gunnery. We are experiencing revolutionary technology that makes our aircraft vulnerable at any altitude, any speed, day or night. The Americans are producing these fuses in quantities that allow unlimited expenditure. Every Allied vessel, every Allied anti-aircraft battery will eventually mount this system. We must revise our operational doctrine to account for engagement zones where aircraft survival rates approach zero. Oberst Heinrich Vogel finally acknowledged the evidence on July 15, 1944, after reviewing 43 consistent engagement reports. He wrote to Luftwaffe High Command, "The Allied proximity Fuze represents a greater threat to Luftwaffe operations than enemy fighter aircraft. Our fighters can engage American P-51s with tactical parity. Our bombers cannot survive engagement with VT-fused anti-aircraft fire. We must either develop equivalent technology or revise operational doctrine to avoid engagement zones entirely. The current loss rates are unsustainable." Willow Run, Michigan, April 1944. Ford Motor Company's Willow Run plant produced one B-24 Liberator bomber every 63 minutes. The facility employed 42,000 workers operating 24 hours daily across 3 shifts. The assembly line stretched 1.2 miles through the single largest manufacturing space in the world. Every hour, another B-24 rolled off the line, complete, fueled, and ready for delivery flight to modification centers. Every day, 38 bombers entered service. Every week, 266 aircraft joined the fleet. Every month, 1,064 heavy bombers, each one capable of delivering 8,000 pounds of bombs 2,000 miles, joined the strategic bombing campaign. Americans discarded more aluminum daily at Willow Run than Germany allocated to fighter production weekly. The machining process that created wing spars removed 23% of the raw aluminum stock as chips and filings. Daily aluminum waste at Willow Run, 16.2 tons. Weekly German allocation of aluminum to Messerschmitt for Bf-109 production, 14.8 tons. The waste from one American bomber factory exceeded the entire allocation to Germany's primary fighter manufacturer. Workers at Willow Run threw away defective hydraulic assemblies that Germany would have rebuilt 3 times. Quality control rejected any component that didn't meet specification, regardless of functionality. Rejected parts went to scrap. Germany rebuilt, reworked, and reused components until they failed catastrophically. American abundance allowed perfection. German scarcity required compromise. A hydraulic pump that leaked slightly went into Willow Run's scrap pile. The same pump would have served in a German aircraft until complete failure. The cafeteria at Willow Run discarded more meat daily than German aircraft workers received monthly. Workers ate subsidized meals featuring beef, pork, and chicken. Cafeteria waste from a single day included 940 pounds of edible protein. German aircraft workers at Messerschmitt facilities received 180 pounds of meat monthly per worker, distributed across 2,200 employees. Willow Run's daily waste equaled 5 days of German rations for an entire factory. Steel scrap from a single day's drilling operations exceeded Germany's weekly allocation to aircraft cannon production. Every B-24 required 14,200 drilled holes for rivets and fasteners. Drilling removed steel as waste chips. Daily steel waste, 8.7 tons. Weekly German allocation of steel to Mauser for MG-151 cannon production, 7.2 tons. One American factory's drilling waste exceeded Germany's allocation to weapons manufacturing. The fabric waste from installing gun turrets exceeded Germany's monthly allocation of canvas to all aircraft production. Each B-24 required 47 square feet of specialized fabric for various applications. Waste from cutting and fitting, 9 square feet per aircraft. Daily fabric waste at Willow Run, 342 square feet. Monthly German allocation of comparable materials to all aircraft manufacturers, 280 square feet. American waste exceeded German allocation. Major Wilhelm Adler reviewed American production capacity reports in August 1944 with growing despair. In July 1944, American factories produced 9,113 aircraft. German factories produced 3,538 aircraft. American factories produced 4,278 heavy bombers. Germany produced 0 4-engine heavy bombers. American factories produced 2,447 4-engine heavy bombers with crews trained and ready. Germany is training 340 pilots monthly and losing 520 monthly. The mathematics are catastrophic. We cannot sustain current loss rates against an enemy whose production capacity exceeds ours by factors of 3 to 5 across all categories. August 18, 1944. Normandy Front, France, 14:23 hours. The Luftwaffe launched Operation Donnerkeil, a coordinated strike by 87 Focke-Wulf FW-190 fighter bombers against Allied shipping concentrated off Omaha Beach. The operation represented one of the largest single German air efforts since D-Day. Intelligence suggested concentration of high-value targets including tankers, ammunition ships, and headquarters vessels. The FW-190s carried 500-kilogram bombs and approached from inland at wave-top height to avoid radar detection until the final attack run. At 1,423.15, the formation popped up to 600 feet for their attack run. Allied radar detected them immediately. At 1,423.22, 47 Allied destroyers, cruisers, and specialized anti-aircraft vessels commenced fire with 5-inch and 4-inch guns equipped with VT fuses. At 1,423.35, the first FW-190 exploded. Elapsed time from engagement to destruction, 13 seconds. Kill time, 13 seconds. At 1,423.41, 3 more FW-190s disintegrated simultaneously from multiple VT-fused hits. At 1,423.53, the formation began breaking apart as pilots instinctively evaded, dropping their bombs prematurely and turning away. At 1,424.12, 14 FW-190s had been destroyed. At 1,424.47, 23 aircraft were down. At 1,425.31, the survivors fled back toward German lines, many trailing smoke and damage. Enemy aircraft destroyed. 31 FW-190s shot down immediately, 12 more crashed before reaching German territory due to damage. Total losses, 43 aircraft, 43 pilots. American losses, 0 ships damaged, 0 ships sunk, 0 casualties. Kill ratio, 43-0. The ammunition expended in this engagement totaled 847 VT-fused shells. Standard barrage doctrine would have required 8,700 rounds with uncertain effectiveness. The VT fuses achieved 90% reduction in ammunition expenditure with 100% increase in lethality. The fuel consumed by the Allied vessels maneuvering during this engagement totaled 12,400 gallons of diesel fuel. The Luftwaffe allocated 11,800 gallons of aviation fuel weekly to Jagdgeschwader II, one of its premier fighter units. The fuel consumed in defensive maneuvering during one engagement exceeded a German fighter wing's weekly allocation. Franz Müller witnessed the engagement from the ground near Caen. He had been reassigned to forward air control after his recovery from the Channel ditching. He watched through binoculars as FW-190s exploded in midair, their pilots having no time to react, no chance to evade. This wasn't combat, he would tell interrogators later. This was systematic annihilation. The shells knew where the aircraft were. They exploded at the exact right moment. Our pilots didn't fight. They died. The engagement lasted less than 3 minutes, 43 aircraft destroyed. I saw pilots burning in their cockpits, falling into the channel. The Americans didn't even use their fighter aircraft. Just ships, just shells that thought. At 14:42 hours on August 18, 1944, Oberst Heinrich Vogel led a desperate strike against Allied armor concentrations near Falaise. He commanded 19 Bf-109G fighters carrying bombs. The mission was routine ground attack, the kind Vogel had flown hundreds of times across 3 fronts. At 1,442.33, American M19 tracked anti-aircraft vehicles engaged the formation with 40 Bofors guns firing VT-fused shells. At 1,442.51, the first Bf-109 exploded. At 1,443.07, 3 more aircraft fell. At 1,443.34, Vogel's aircraft took multiple fragment hits, severing his right aileron and wounding him in the shoulder. At 1,443.49, a VT-fused shell exploded 4 feet from his canopy. Fragments penetrated the cockpit, killing Oberst Heinrich Vogel instantly. Elapsed time from engagement to death, 76 seconds. Kill time, 76 seconds. His aircraft impacted a wheat field at 1,444.03. He was 42 years old. He had flown combat missions since Poland. He had 31 confirmed victories. He died not to enemy fighters, not to enemy pilots, but to an automated proximity fuse manufactured by a former department store clerk in Rochester, New York, who inserted vacuum tubes into housings every 18 seconds for $1.85 per hour plus overtime. The engagement summary recorded: 15 Bf-109G fighters engaged, 11 destroyed, 2 damaged and crashed returning to base, 2 escaped. Total enemy losses: 13 aircraft, 13 pilots including 1 Oberst with extensive combat experience. American losses: 0. Kill ratio: 13-0. Duration: 3 minutes 18 seconds. This wasn't combat. This was systematic annihilation. October 1944, Allied Intelligence Center, London. Major Wilhelm Adler sat across from British interrogators in a pleasant room with tea, biscuits, and professional courtesy. He had surrendered on September 23 after his reconnaissance aircraft developed engine trouble over Belgium. He requested to speak with technical intelligence specialists. He had information to share. "We were not defeated by better soldiers, but by better factories," Adler said carefully, measuring his words. In January 1944, Germany produced 2,140 aircraft. America produced 7,899 aircraft. By July 1944, Germany produced 3,538 aircraft. America produced 9,113 aircraft. A single American factory, the Ford Willow Run plant, produced more heavy bombers monthly than our entire industry produced aircraft of all types. Your proximity fuse represented the weaponization of American industrial capacity. You didn't just outproduce us. You produced weapons that made our tactical advantages irrelevant. The British officer nodded, taking notes. "Tell us about the operational impact." "We calculated that Allied anti-aircraft systems equipped with VT fuses achieved kill rates between 73% and 91%, depending on engagement conditions," Adler continued. "Our previous experience suggested anti-aircraft kill rates of 4% to 7% for conventional systems. You increased lethality by a factor of 15 while simultaneously reducing ammunition expenditure by factors of 8 to 12. The mathematics became impossible. We could not train pilots faster than you killed them. We could not produce aircraft faster than you destroyed them. And your systems required only modest technical training to operate effectively, while our systems required years of pilot development and considerable skill." Franz Mueller provided additional testimony on October 19, 1944. "I flew combat operations for 2 years before I first encountered the proximity fuse in June 1944. I survived 4 more months. I watched the Luftwaffe disintegrate. In June, our squadron had 18 operational aircraft. By October, we had 4. We didn't lose pilots to enemy fighters. We lost them to anti-aircraft fire they couldn't see, couldn't predict, couldn't evade. I saw pilots with 200 combat hours die in their first encounter with VT-fused shells. The shells were smarter than we were. They calculated intercept solutions automatically. They detonated at optimal range automatically. They achieved kills automatically. We brought skill and experience. The Americans brought automation and abundance." British interrogators compiled additional testimonies from 127 captured Luftwaffe personnel between June and October 1944. The consistency was remarkable. "Your shells exploded at exactly the right distance," one pilot reported. "Not too close, not too far, but precisely where fragments would saturate the kill zone." Another: "We tried everything. Different altitudes, different speeds, different approach angles. Nothing worked. Your guns tracked us perfectly. Your shells found us perfectly. Your fuses timed detonation perfectly." A third: "The worst part was knowing that the men firing these weapons didn't need to be expert gunners. Your technology made expertise irrelevant. A crew with 1 week's training achieved better results than our crews with years of experience." A Bf-109 pilot captured after his aircraft was destroyed over France in September provided technical analysis. "We estimated that Allied vessels equipped with VT-fused anti-aircraft guns could engage and destroy targets at rates exceeding 1 aircraft every 30 seconds per gun mount. A destroyer with 8 mounts could theoretically destroy 16 aircraft per minute. The mathematics were inescapable. We could not concentrate forces large enough to overwhelm your defenses before the defenses destroyed our forces." Production statistics captured from German records confirmed the scale of disparity. American production in 1944: 96,318 aircraft, including 16,331 4-engine heavy bombers. German production in 1944, 39,807 aircraft, including 0 four-engine heavy bombers. American proximity fuse production in 1944, 22 million units. German production of comparable electronics across all applications, 89,000 units. A single American technology represented a 247-1 production advantage. Single American factories exceeded entire German industries. A FW-190 pilot who survived the August 18 Normandy engagement provided the most comprehensive testimony. They could lose 400 aircraft weekly and replace them in 5 days. We lost 400 aircraft weekly and couldn't replace them in 3 months. They could lose 10 ships and build 20 replacements in a month. We couldn't replace 1 destroyer in a year. Their excess capacity exceeded our maximum effort. This wasn't about courage or skill or determination. This was about industrial mathematics. They produced more proximity fuses in 1 month than we produced vacuum tubes annually across our entire economy. You cannot win wars against such disparity. The final summary compiled by British intelligence in November 1944 concluded, German military capacity has been systematically dismantled by Allied industrial superiority weaponized through technology. The VT proximity fuse represents not merely a technical innovation, but a demonstration of democratic industrial capacity operating at scales totalitarian command economies cannot match. Free workers outproduce controlled labor. Market-driven innovation exceeds centralized planning. Democratic coordination achieves results authoritarian direction cannot replicate. December 1944, Statistical Summary. From June through December 1944, VT-fused anti-aircraft systems achieved the following documented results. Aircraft destroyed by VT-fused naval anti-aircraft systems, 2,347 confirmed, 892 probable. Average engagement time, 47 seconds. Average ammunition expenditure per kill, 3.2 shells. Conventional systems required average 38 shells per kill with average engagement time of 4.2 minutes. Aircraft destroyed by VT-fused ground-based anti-aircraft systems, 1,893 confirmed, 674 probable. Average engagement time, 52 seconds. Average ammunition expenditure per kill, 4.1 shells. Total Luftwaffe losses on Western Front June-December 1944, 8,447 aircraft. VT-fused systems accounted for 50.2% of confirmed kills despite representing only 34% of anti-aircraft systems deployed. Luftwaffe pilot casualties Western Front June-December 1944, 5,283 killed, 2,197 wounded, 1,894 captured. Pilot replacement rate, 840 monthly. Loss rate, 1,014 monthly average. The mathematics were catastrophic. Germany lost pilots 20% faster than training systems could replace them. American VT fuse production June-December 1944, 15.4 million units. Cost per unit, $18. Total program cost, $277 million. German equivalent electronics production same period, 67,000 units across all applications. The numbers told the story. Industrial capacity, weaponized through technology, deployed by democratic societies that chose to fight, proved decisive. The VT proximity fuse proved that industrial capacity, when coupled with technical innovation and manufactured at scale by free workers in market economies, could overcome tactical superiority, strategic position, and ideological certainty. Free workers outproduced slave labor and controlled workers across every category. Democratic cooperation exceeded totalitarian command in coordination, innovation, and sustained output. Industrial abundance buried ideological superiority under 22 million proximity fuses, each one representing 18 seconds of labor by a worker earning $1 and 85 cents per hour who chose to work there. The technology itself was elegant. Miniaturized radar, ruggedized vacuum tubes, automated fusing, reliable detonation. But the revolution was industrial, converting complex electronics into commodity products manufactured by workers with minimal training using processes designed by engineers who understood that making products wasn't the goal. Making product-making systems was the goal. Germany had engineers who could design radios. America had engineers who could design radio-making machines, operated by department store clerks, who produced more radios per shift than German craftsmen produced per month. September 12, 1943, Berlin. Oberst Heinrich Vogel had laughed at American claims of proximity fuses that could sense aircraft. He dismissed the reports as propaganda. He trusted in German technical superiority, German pilot skill, German tactical excellence. The mathematics of combat experience and equipment performance seemed to guarantee German superiority. August 18, 1944, Normandy. Oberst Heinrich Vogel died at 1443, 49 hours when a VT-fused 40mm shell exploded 4 feet from his canopy. His combat experience, his 31 victories, his tactical expertise, his courage all became irrelevant in 76 seconds of engagement with automated technology manufactured by semi-skilled workers in a country he believed industrially inferior. Their mockery became history's most expensive miscalculation, measured in 8,447 aircraft, 12,000 pilots, and the complete collapse of Luftwaffe operational capacity over Western Europe. The lesson remains: dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity invites catastrophic miscalculation. The VT proximity fuse proved that free workers in market economies, coordinated through democratic institutions, can outproduce, out-innovate, and ultimately defeat authoritarian systems that mistake centralized control for efficiency and ideological certainty for capability. The mathematics of industrial democracy proved decisive. Free peoples, when threatened, don't just fight harder, they build better, they innovate faster, they produce more, and they win.